So hi everybody, my name is Damien, as you hopefully know at this stage. I'm your online instructor for this course. I'm sure I'll probably communicate and inform with some of you over the last few weeks. I just want to go through a video, and I said I don't do an awful lot of videos for these courses. I don't just believe in putting a video up there just for the sake of it, because I know a lot of you guys will probably end up using YouTube for all these different videos. But I have put a couple of videos up for a couple of labs. There's one for this lab, Lab 9, and I'll also be a very quick one for Lab 11. Okay, so now again, I know some of you know classful subnetting and all this class custom subnet masks, but I just want to go through some stuff. Now all this is done on the PowerPoint, to be fair, but I just want to go through some examples and maybe say things on the video that maybe are not included in the slides. And I do try and include as much as I can in the slides, not just for online students, but also on-site students as well. So again, like I said in the welcome video, there's three areas to kind of look at. You got classful subnetting, which really isn't used much anymore, but I think it'd be kind of irresponsible not to address it, because like I said, classful subnetting, classes like A, B, C, D and all this stuff, I think it's key that you guys know it, even though it's probably still not being used out in the real world that much at the moment. Like I said, in 358 in particular, we're going to focus more on classless and on VLSM. So this class is purely about classful subnetting, okay? And I just want to go through some examples in the video here that are done in the slides, but maybe to clarify any points that are not. So this is hopefully what you should know so far, all right? Things like the IP address, the subnet mask, the default gateway, which again is our local router connection, classful and classless subnetting. Again, this is what you should know just from reading the slides, okay? Network ID, broadcast address, and the term usable. So just want to briefly go through these very quickly, and I'm not just going to ramble for the sake of it, okay? So we know what an IP address is. Look, there's different layers of addressing in networking, okay? And the key thing to remember is that when the packet comes down the layers of the OSI, we know stuff gets added to the data. Headers get added, okay? So the layer 4 header gets added, then the next layer, then the next layer, and eventually your packet will go across the wire. And that going across the wire, just to say, is covered in 358 encoding process, but that will just a minor point. So the packet then hits the receiver, right? Now this receiver could be a router or it could be a host, okay? So when the packet, let's say, hits the router, right, or receiver, it strips off the layer 2 information, right? Because remember, it's going up and it kind of hits the data link layer. So the data link layer will look inside the layer 2 information and say, is that MAC address for me? Yes, it is. Happy days. That's the goal. So then what happens next? It then goes up to the network layer. And the network layer, as we know, well, hopefully you should know, is about the IP address, which we're looking at here. And it says, right, is that my IP address? Yes, it is. Okay, it looks inside the header, looks at the destination, it says, that's mine. And then when it knows it's his, then it goes up to the next layer, level 4, which is the transport layer. And at that layer, it kind of looks at the port number and says, right, which application does this packet need to go to get processed? So that's how that happens. And if on the router this happens, let's say in the router this happens, so let's now jump back to the router for a second. The packet hits the router looks at layer 2 information, says, yes, that's my layer 2 information, looks at the next layer, so in the router, it goes up to layer 3. Remember, the router only has layers 1, 2, and 3, right? Routers don't have layers 4, 5, and 6, and 7, just layer 3. So then at layer 2, it says, yes, this is my MAC address, happy days. Then it goes to layer 3 and says, is this my IP address? Nope, it's not. So what does it do? It repackages that layer 2 information, it repackages it, now puts its MAC address as the source, and probably the next router as the destination's MAC address, and it's sent it on its merry way out whatever particular port, whatever particular interface on the router, okay? So that's where the IP address fits in. It's critical. It's like the second part of the addressing. So you got the MAC addressing, IP addressing, and then the port addressing. They're the kind of key root 3 addresses. So as you've also seen in the presentation, you kind of, IP address nowadays come with a subnet mask. It's a bit like Beavis and Butthead, Laurel and Hardy, in a sense. You don't really have one without the other, because the subnet mask is key, okay? It kind of tells us a bit of information, like how many bits are used for the network, how many bits are used for hosts, and stuff like that. So really, really key piece of information, okay? And needless to say, those who are on the same subnet can communicate directly, but you'll probably get that. Next thing is the default gateway, which is your local router connection. Okay, that's simply what it is. It's your local router's connection is the default gateway. So like what happens, you basically have a packet and the question has to be asked. And this is in part N of this lab booklet, believe it or not, of lab 9. It's the ANDing process. So, you got to ask yourself, okay, I've got a packet. Is this going to go somewhere local or does it need to go somewhere beyond my router? And that's the question. Okay, if it's local, you do the ANDing process. You basically have your IP address, your subnet mask. You've got their destination IP address with your subnet mask. You do the ANDing process, and it tells you whether it's local or remote. If it's local, grand, you can just do an ARP request. If you haven't got the MAC address, you haven't got the IP address, MAC address, send it out on its merry way to local. If it's remote based, you're going to end up sending it off to the router. Because the router enables you, once you send it to router, it'll then put it out there on the internet for you, and it'll basically do its routing process. Okay. We then have classes and classful subnetting. Like I said, we are now living in a classless world. Okay. Like I said, you might go to some network engineers and say to them, "What are the 5 standard classes?" And they may not know, because as I said, someone was just living in a classless world. And you can see by the presentation the advantages of living in a classless world. Remember, classes was one way of trying to conserve IP addresses or use available IP addresses. By saying classes, I now give you an IP address like 158.2.6.12. In classless world, that is no longer a class A, B, C, or D. So you go to your, you can literally go to whoever and say, yeah, look, I just want this number of bits because I just need this number of hosts or this number of subnets, and he'll just give you, 158.6.6.6, and he'll say, whatever slash do you want? What slash do you want? Either slash 20, slash 25. That's up to you how many kind of subnets, how many hosts that you want. That's where really classes will come in. Network ID, we know straight away, we're going to look at that in a few minutes. What is the network ID? Okay, like we said, if you take a standard Class C is a /24 CRD notation, or 255.255.255.0. So your network ID will essentially be the .0. Okay, so let's say it's 192.168.1.0. So that .0, that's the network ID. Okay, broadcast address, again, broadcast, we know what a broadcast is. Packet, we got unicast, multicast, the broadcast, the packet is sent to everyone. And how we do that? Well, basically we'd make it 255. Okay, so we know kind of the .0, so everything in between, the .1 to .254 are available IP addresses. That's what we mean by usable. So if you think of a Class C that way, where Class C has the last octet, 8 bits gives us 256 possible IP addresses. We know we can't use the first, and we can't use the last. First is the network identifier, last is the broadcast, everything in between is usable. So the .1 to .254, that's our usable. So that's just a brief summary. And again, like things like default gateway, router, we're going to do a lot more routing in IFT 489, okay? So for now, we just want you to understand that is your local router. And remember, once a packet gets on the network, the routers can do the rest of it. So once it hits that first router, it will start bouncing away to get to its destination, all right? In 358, we look at things like maximum transfer unit. I'm trying to sell 358 here, but if you can imagine a packet leaving your computer, it takes a certain route to get there. It'll go across multiple wires. But sometimes these wires won't accept a packet of a certain size, the MTU. So what is the maximum packet size that is allowed across basically each connection? And sometimes that's smaller than what the original packet is. So in 358, we look at ways of counteracting that. And that's a big difference between IPv6 and IPv4. But anyway, so hopefully that gives you a quick summary of what you should know so far with these terms, okay? So with that in mind, I was going to look at a quick example. And again, I know some of these examples were done in the actual presentation, so I just want to go through one of these. So this, one thing I was told when I was learning networking years ago, my teacher said to me, if you can subnet a Class C, you can subnet anything. So I really tend to focus on Class Cs in classful. Class Bs and Class As, they just have more zeros, more digits, more binary values. But if you can do a Class C, you can still apply the same logic to a Class A and Class B, okay? So let's just have a quick look here. I've given you a network address, and I basically asked you questions. What's the subnet mask? So what's the standard subnet mask? We know it's 255.255.255 or /24, whatever you feel happy doing. Host bits, again, we know it's 8 host bits. This is a Class C address. Number of hosts, like we said, it's usable. If you're not asked, assume it's usable. Fair enough. So if you're not asked, usable. So in this case, 254, hunky dory. Network ID, like we said, just a 0, so it's just 202.4.1.151.0. No problem there. Broadcast, .255 at the end. First host, 1. Usually the first host address given to the router, not always, but just it's a common thing that's usually done. And the last host address is the .254. So that's just a quick example there. So that's just, again, here's a Class B example. I don't tend to focus on Class Bs nowadays that much. And another reason, to be honest, is, how can I say this to you, we only have a week to do this, right? And when we do 358, we'll have a little bit longer, because in 358, you'll have a revision time doing some Classful and a week or two doing VLSM. So we don't have an awful lot of time doing this. So I'm not going to try and cram everything down to once. If you can just really understand Class C and apply the same logic to A and B, we're in business, okay? So like I said, this is a Class B, same principle, /16. Number of hosts, in this case, it's 16 host bits because we're using the last 2 octets. Network ID, the last 2 octets are 0, 0. Number of hosts, again, in this case, it's 2 to the 16 is 65,536. You're going to minus 2 of them. We get that broadcast. I think you should be okay with that. All right. So let's just have a quick look if we can. Now, I think this should hopefully work. I have one of these little pens here. So we're just going to go through a quick example. Subnet mask, as I said, you can do either the 255.255.255.0 or the /24. Let's put in the word or there. Okay, or whatever you want to go with. Number of host bits, as we said here, this is 8. You know, number of hosts in this case, so number of host bits, so it's going to be 2 to the 8 minus 2, and it's going to be 254. Okay, we always lose 2. Network ID, I'm going to just be network ID, that's that value there. Oh crap, I just got it. I'll just write it in just so we're complete. 215.3.5.0. That's network ID. So that's like our network name. It's a network ID. First host address, as we said, is going to be a .1. Last host .254, and broadcast is .255. So as I said in the welcome video, I just want you guys to really understand the basics of networking. That's all I'm trying to get here. You know, you've got 7 weeks to do this. Some of you guys are in the field. Some of you guys are probably laughing, just going, I done this years ago, I don't do this anymore. I get that. But for some of you who are new to networking, this is key that you understand some of this process, because all this slash stuff, 24, that's carried over into classes. Okay, so while Classful may not be still out there in the real world, a lot of places are still using it. Most places are still using IPv4, right? And back in the 2008, I think, Olympic Games, where it was in China or whatever, they were using full-blown IPv6 for their network. So, you know, things aren't happening as quick as some people think they are, and sometimes things are happening quicker than they think they are. I mean, you get what I'm talking about. So let's jump to the next example if I can. Okay, this is a quick thing of what a network is before subnetting. It's just like one big network where, you know, you send the packet and everyone gets it, etc. So it's just one big classroom. You know, so you can't break up your administration staff, you can't break up your financial, they're all in one network. But the idea of subnetting is that you take this big network in here, like this one here, you take it and you basically just make small little groups from it. That's all you're doing, okay? So if you take a Class C, we know in a Class C that we've got the last octet used for the hosts. And rather than just having one big group of 256 or 254, whichever you want to go with, we're just going to break those up into small little groups. Okay, that's what we're doing. So rather than having one big group of 256, we're not going to do that anymore. We're going to break them into small little groups. But ultimately in a Class C, all those groups will inevitably give me 256. That's the magic number when you're talking Class C. I hope that kind of makes sense to you. And that's all this is. Here we just use a Class B address, but it's the same principle. Okay? So here's all the subnet mask, and we've briefly looked at the subnet mask. It's key to subnetting. So again, you can see all the different varies here for the CRTR. They're all down here. Okay, these are all the different values down here. And these are key. Okay, as you can see here, just by switching the values, we've got /8, /10, /11, all the way down. Because traditionally, at the moment, we were just kind of familiar with, you know, 8, 16, 24, we get it. But there's now all these extra values as well, and they should make sense to you, right? What are you doing? You're just basically flipping on the next bit. So if you take /8 means the first 8 bits are turned on. /9 means you're now just turning on the next bit. And we know that leftmost bit has a value of 128, correct? Because 128 plus 64 plus 32 plus 8 plus 4 plus 2 plus 1 gives you 255. So we know that if it's flicking on that left bit, the first bit of the next octet, that's where we get the 128. We get the 10 by putting on the next 2 bits. So it's hopefully I got what I'm saying to you. So all the first stacks that's turned on, that's where we get that little 255 from. And this 192 is so remember, if you think about it, so we've got 255, then we've got the next 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You get where I'm coming from with this, and then it's those 2 bits are turned on. and it's 128 plus 64, and that'll give you the 192 over there. Okay, so that's where this comes from. All right, let me just do a bit of rubbing out here. This actually works well. Okay, sweet. Okay, so just want to move. Let's get that out. So moving on to the next slide. This is important when you're doing subnetting. All right, and again, some of you've probably seen this in slides. You might be familiar with it. You might know what it is. Okay, so we have a binary values here, like we said. There. All right. So the question is, I'm going to focus on the number of hosts first. If we have one binary value, how many possible hosts can we have? Right? Remember, a binary value can have two values, 0, 1. So we've got two values. Makes sense. Okay. If we have two binary values, how many hosts can we have? So think about it. We've got two x's, right? But each of those x's can have either one or two values, correct? They'll either be a 0 or a 1. So how many combinations can you have with that, in a sense? 0, 1, 1, 0, 0, 0, sorry, my mistake, just rub that out. 0, 0, 1, 1. 4 combinations. Okay, so that's what this is. So again, if I go to 8 bits right here, how many can I have? Okay, does that make sense? Okay, so hopefully that's what this is. So how many binary values will basically give me? So again, I'm going to have 256 hosts for my entire 8 bits down here. Okay, does that kind of make sense to you? Okay, so this is key. And also the key thing is, if I have two hosts, I'm just going to rub this out here. Just bear with me 1 second. I'm going to rub all this. Here's the real magic with this little diagram. If I have two hosts, so I'm going to have two hosts in every subnet, right? So I know 256 is how many hosts I have overall. But I'm now going to break down to small little subnets. The ones over here, okay? But in each of these, I'm going to have two hosts. If I've got two hosts in every subnet, how many subnets can I have? Well, the magic number is 256. So what multiplied by 2 is going to give me 256? Okay, my number of subnets, right there. So you always go diagonally across. And hopefully all those should give you 256. So I'm now just creating small subnets of hosts. And how many hosts per subnet will dictate for me how many subnets I'm going to have. And vice versa. You know, if you're going to have 8 subnets, some of the questions in the lab are given both ways. If I'm going to have 8 subnets, how many hosts can I have in each? Well, it's 8 into 256, and I should get 32. So in a class C, the magic number is always 256. Okay, so this diagram, let me just rub out this for a second. This is really nice. I kind of like this. This diagram is really important. So let's put a big NB. Note the benefit. It's Latin. I used to do that in school. It's NB, whatever you put important. It's really important that you understand this diagram. So these are the binary values for our bits. And this is where we get to 200. This is where I said to you, 128 plus 64, that's my 192. Okay, you add the 32, get 224. You add the 16, get 240. You add the 8, 248. You get where I'm going with this, all the way to 255. Sorry. Okay, so it's really key. I think this is a really important diagram to understand how you do a bit of this early classful stuff. Okay, so like I said, we're going to really focus on an awful lot on the class and the class C. I think in the lab I even give maybe one class B, and that's not that much of a stretch. All right, so I just want to jump on, if I can, to the next slide. Here's the question. So how do you figure out a subnet? Well, again, you decide how many hosts and networks that you need, and you just borrow bits to accomplish the task. So it really is like how many hosts, and that's the questions in the lab that I've asked you. I've said to you, you need this number of hosts, that number of things. What subnet do you need? All right, so let's have a look at an example of what we're talking about here. All right, so this is the first problem. So I've said to you, number of subnets 14, number of hosts needed 14. Okay, and there's our IP address right down here. Now I filled all these in. The next question is going to be blank. Okay, so what's the address class? Class C. Okay. Remember, key thing to remember is there's 5 address classes. There's not 3. Even now, my 358 class that I do is now, and 489. Someone should say, yeah, there's 3 address classes. No, there's 5. A, B, C, the ones that are used. D and E, we know what they're used for. Multicasting, experimental use. So just remember there's 5 of them, okay? So this is a class C address. What's the default subnet mask? 255.255.0. Or how else could I write this? It's going to put in or/24. Don't mind how you do it. Let's leave this And let's leave this till the end. They're the last two that I always do at the end, okay? So number of subnets, okay? So 16. Now here's the key thing, I just want to clarify this. Years ago, the idea was you would always lose two subnets. You'd use the first, you'd use the last. That's kind of no longer the theory, okay? It's no longer out there. You no longer use two of them, okay? So I don't mind how you do this. If you're old school, some of you maybe, you could say, right, I'm going to lose the first, lose the last. The idea behind that was, and we're going to look at this in a few minutes, when you list all those subnets, if you have the first subnet, you don't know whether that ID was for the global subnet or for the local subnet. It's the same with the broadcast. So again, it's your call if you want to do that. If you want to keep that philosophy going, you lose the first, lose the last, fine. I'm not knocking that. But that's no longer the case. They now say you don't lose them anymore, okay? So in this case, how many subnets? 16, okay? That gives me that 16 there, okay? Perfect. If we lose two, we'll have 14. Check. Happy days. Number of host addresses. We know we need 14 usable. So in this case, we need 16. Correct? Happy days. We lose the first. Why? It's the ID. We lose the last. Why? Same thing. Broadcast. So happy days. Number of host usable is 14. 14 matches up there. We're in business. Okay. Then the question is number of bits borrowed. Right? Remember. Here's what we're doing. We are looking for a subnet ID. So we have one global network, right, up here. And this is just one big circle. That's what that is. We're, however, going to break that into smaller circles, little subnets. And in our case, we're going to break them into what? 16 of them. That's what we're going to do. So I'm not going to draw I won't draw 16, but I'll draw a few more. We get the general idea. Each of these is going to have how many in it? 16 in it. Agreed? 16 by 16 gives me 256. Yep, think of those. Yep, touch wood. Okay. Each of these, however, I'm going to put 16 in a few more, so 16 hosts. Each of these requires its own ID. Hence why it's called a subnet ID. So where do we get this subnet ID from? Well, we're going to borrow it. We're going to borrow some bits off our hosts. Because remember, at the moment for this question, we have 8 bits for Class C. But what it's now saying is we don't need the whole 8 bits. Why? Because we're only looking for 16 hosts, 14 usable. Okay, so we're going to borrow some bits as my subnet ID. So in this case, how many am I borrowing? Well, I'm borrowing 4. Why? How many hosts do I need? 14. This line is the answer. Here is going to give me 16. That's what it says 16 right there. If I take the 4 right hand side bits, 2 to the 4 gives me 16. Sweet. But we know at the start that traditionally all these bits here are used for my network ID. No longer are they used for my host, I should say. They're not all going to be used for my host. I'm only going to use 4 bits for my host, and I'm going to borrow these 4 bits for my subnet ID. I'm going to borrow them. So how many bits have I borrowed? I've borrowed these 4 right here. Sorry. That's what that 4 is. Okay? So that gives me that one. I can rub out this and put a little checkbox. All I've left to do is this one, custom subnet mask. If I add up 128, 64, 32, and 16, touch wood, it should give me 240. And that is my custom subnet mask. And that, ladies and gentlemen, is how you do this type of question. Okay? Now all that's left, which we'll do that in a question in a few minutes, is what are these separate subnets? And that's what we'll look at in a few minutes. Hopefully you're all okay with this. Okay? I can explain A better than this. Hopefully I'll get a general idea. Okay? So I just want to go on to the next one. So here's another problem. Let's have a quick look at this one. Okay? And normally if I'm in a classroom environment, I'd give the class a minute or two, but since I'm on a video, you can pause this if you wish to do it yourself. So address class, we're going to go straight away to Class C. Default subnet mask, and again, just to keep things straightforward, we'll just do a /24, or you can do 255, 255, 255, that's 0, whatever. We're going to leave this bad boy. We're going to leave this bad boy. Okay, we're not going to touch those for now. Okay, we've got the number of hosts, number of subnets. Number of subnets, I'm going to put 8 in there. Okay, hopefully you all can see that. Number usable, based on the logic from before, but maybe not now, is 6. Okay, nowadays, again, you can argue the 8 of them are usable, that's fine, but for this type of question, we'll go with 6, we'll follow the pattern. Number of host addresses, okay, so we've got 2 of them. So if I do, let's see, so I know the number 8 is over here, this number of subnets I need there. Number of host addresses, diagonally, I'm going to go 32. I'm going to go 32 in there. Number usable, as we know, is 30. Before we move on to the last 2 parts, do these parts match our criteria? Let me see, number of subnets, 6, 6, and 30, 30, check. That's check, and that's check. Okay, I think we're all good. So, next part is number of bits borrowed. Okay, so how many bits? So we noticed 32, so we're gonna, the line actually, now remember, this line will not always be here. I've kind of been pretty helpful. All right, I've given you this thing here, and some of the questions in the lab, this little box will not be there. Okay, this is just like to help you get started. And in particular, this line will not be there. That's really helpful having the line there. Okay, so in this case, the line is correct. Okay, so we know we're going to use these for our hosts. 32 matches up there. So these are 5 bits. Agreed? Well, I'm talking to myself here, but yeah. Okay, so how many have we borrowed? We've borrowed these 3 here. 3 bits borrowed. And if we turn them on, we're going to have 128 plus 64 plus 32. Hopefully, should give me 224. So it's going to be 255.255.224. Now, quick question before we go on, and I know this is going to rub out, which is going to be quite annoying. We've got 224 here. Okay? Could we write this a quick way? Well, let's have a look. We said 224 right there. So you could have wrote that /27 if you wish. Now this is all going to be gone, but hopefully you get the, oh no, it's still there, great. We can actually do or/27. Either way, don't mind. Hopefully you get that. Okay. So last thing just to look at before I go on. Again, this is a class B, same principle. I'm not going to go through it, it really is. You're just looking at bigger numbers. And just look how this evolves. So this goes from 256. Look where that goes. That then goes up to 512. So it kind of doubles, which is natural, right? You're kind of doubling each time. 512, and again, same thing. So in this case, the magic number is 65,536. So again, it just goes on with it. And again, if you look at the slides, I've got a Class A example as well. Same principle. 60 hosts, 1,024. So here we're looking here to here. That's where that value goes in there. Okay? Hopefully that makes sense to you. Okay? I think that's right. Let me just check. 64. Oh, 124. So that's all good. Okay? So that's basically Class B done. Okay? So again, it's all about where to put the line. Okay? Let me just check. Actually, I'm incorrect. It's actually, the line is right there. So I'm actually wrong. Sorry, number of hosts is there. Sorry. I was reading the wrong line. That's where we're going. So it's there to there. Apologies, that was my mistake. I was reading the wrong way. So number of hosts on this one up here, bottom line is on this one. So it's this way. So what does that mean? That's where we get 10 from. We borrow all these plus 2. That's the 10 there. So apologies, that was my mistake. Okay. So last thing to look at in this is this. So all this part here for this question is straightforward. We've done it all. What's not is this. This is new. And these answers come from here. Okay, so I'm not going to explain this again. We've gone through all this. So the question is, when we have this, we write out our ranges. So what is the first range? Well, we know here, right, that there's going to be 16 hosts in each subnet. Okay, so if there's 16 in each subnet, what is the first ID going to be? Well, it's going to be this ID here. And that's it right there. So it's the .0. And if we know there's 16 hosts in a subnet, then we know it's going to go from 0 to 15. That's our first subnet. Okay? Our second subnet will be 16. So as you can see, there's a pattern here. All the evens are on this side down here. So you're increasing it. 16, 32, 48. So these are all our 16 subnets. Okay? Traditionally, it said, you say this is invalid, and that's invalid. So you're left with 14. That's traditionally. So this was the first technically usable. Now, like I said, that's no longer the case. So however you answer these questions here, I don't mind. you can answer them in such a way that you're ignoring this one and ignoring this one, in particular this one, and answer them. Or you're saying, I'm actually going to include that one. Because what that means is, when you say third usable, some of you will say that this is the this is the third usable, or some of you will say that this is the third usable. That's your call. I don't mind. I'll go either way, to be honest. Okay? So before we finish, let's just have a quick, hopefully this makes sense to you. So that line is key, that slash, because it tells you how many bits are in a subnet. So if I say to you a /28, /28 means you've got 4 bits left for hosts. 4 bits is what? 2 to the 4. Okay? 16. Okay? So that means there's what? 16 hosts in each subnet. So what's your subnets? 0 to 15. You see what I'm doing already. I can now do them in my head. Okay? If I say /29, gives you 3 bits, 2 to the 8. First subnet, 0 to 7. Get my point. All the way down. So let's just have a quick look at the final example here. We'll do this very, very quickly. I'm just going to put in the values here. I'm just going to do this quickly here. 255/24. We're just going to do, let's see, 4 subnets. We're doing 60. We've got to go 64 here. Number of host address. We're going to go 64. We're going to go 62. We're going to go, I think it's probably 2 over here. And then probably this is like a 192. Okay. And again, we do a 192. If we just jump back, which I'm going to here, it's a 192. I can just do a /26. Okay. Sorry, I just want to do a /26 in here, or /26. Okay. Then the question is, define your ranges. Okay, so we know it's 2 bits borrowed because I remember it's 64, so it's going to give us. So let's just think back to this. Okay, so what is the second subnet range? What are your ranges? So it's 0 to 64. Let's jump back here. Okay, so we're now imagining going to put our line down here. So 0 to 64. Okay, that's the question. So it's now 0 to 64. Okay, so how many bits? If we jump back here, okay, 2 bits borrowed leaves me 6 bits. 2 to the 6. Okay, so we're going to go 2 to the 6. That's going to be 2 by 2. Oh crap! By 2 by 2 by 2 by 2 by 2. So that's 4, 8, 16, 32, 64. Okay, so we're going to have 64. Okay, in 4. That's what we're going to have here. Okay, so we're going to have 4 subnets. So rather than having all these where we've got 16, in this case, we're just going to have 4. 2, 3, 4. That's what we're going to have. Okay, and we're going to start off obviously with 0. So our first one's going to be just going to do it over here, 198.125.50.0, and that's a 0, not a 6. Put that out. 6, and that's going to go to 198.125. Apologies, actually, let me just rub this out and do it down here. This is going to go to 198.125.50.63. That's our first subnet. The next one is going to be from .64 over to .127.128. You get where I'm going. So I'm going to have 4 of them here, and then based on that, what is the second subnet range? So you get where I'm going with this. So in this case, there's only going to be 4 subnets, which is correct. So hopefully that will help you out with this. Okay. So before we finish this, I know it's not brief, but hopefully this has helped you with this lab. Last thing, I just want to go through these sections. So this is the lab 9. Okay. Like we said, let's just have a quick look here. Parts A down to G are straightforward. There's no problem. That's just doing all these binary conversions. Look, you're online, you're at home, you're in your office. I don't mind you guys using a calculator, but just every now and again, just on a pen and paper, just do 1 or 2 of them, just in case someday you're out in the middle of Timbuktu, or maybe you're in some Antarctica and they haven't got a calculator. Might be nice just to know how to do it. So let's just jump to part H, okay? Because I'm going to jump to this part here. This is where it gets a little bit different, okay? So I've just basically said to you, part H, identify each class. Remember, 5 classes, and look for any special addresses. Hint, hint, maybe that one. So while we say the classes A, B, what A, B, and C is, think about what the 127 address is. That's all I'm going to say. But remember, there's 5 classes. Some of the students often always just put A to C. There's not. There's all the way down to A to E. So just remember, I'll give you a little tip there. Network and host identification. So circle the network portion of this address. Purely the network portion is based on what class it is. So here white is a class B, and this white is a class A. Again, this is a class C, so I'll just trot around there to get the general idea. Circle the host portion, same thing. So here the host portion is going to be over here. This is a class C last octet. Not a problem there. Part J, same thing. Using the IP address and subnet mask, write it to network address. So again, you use the two of them together. So in this case, it was 18. We know it's a class B, so that's going to be the network address in there. So in this case, I'll just do one more on here. It's going to be 192.149.24.0 because it's a class C, and they're all used for my network ID, and this will be the subnet. So that's right there. Yeah, that's my first network address in there. That's correct. Yeah, perfect. That's my network address. All right. So you can just follow the rest of them. Part K, host addresses. Again, same principle as this part here. In this case, just put the host address in here. So I'm just basically going to put class C, because I know it is, because it's based on two things. And I'm just going to do, so it's going to be let me just see here, host address here. So you want to do, okay, so you get, hopefully, I'm not going to keep doing all these, but hopefully you can kind of see where I'm going with this, okay? So the host addresses in this case is, that's the IP, that's the subnet mask. Using the IP, write out the host address for each one of these. Okay, so again, it's the same thing for each of these going down here. Next one, correct default subnet mask for each of these. So just identify what's, so again, I just really want you to get the hang of what class these are in. Okay, so again, class A, class B, find out each class, you get the general idea. Okay, this is M. So this is, there's 5 parts to problem M. This is problem 1 I've just looked at. I've gone through problems 1, 2, 4. And this is problem 5. This is a little different. Just spend a minute on this. I've given you an IP address in here. Okay, I've given you an IP address in there. And with that, you have to work out. So here's what I'm asking you. This IP is on a subnet. It's on a subnet. So you've got to list the subnets for this range here. And how would you do that? Well, it's 30. So if I'm using 30 bits for my network, essentially, I'm going to have 2 bits left. Okay, so if I've got 2 bits, how many is going to be in my each subnet? 4. So it's going to be 0, it's going to be 0 to 3. Okay, 4 to 7, 8 to 11, all the way down. When do I stop? You stop when you find where 37 is, because that's an IP address in one of these subnets. When you find out which one of these subnets it's in, then basically you have to find the broadcast of that subnet, identifier, range, and then is the address usable or not. What we mean by usable, is it the network? Remember, it can only be usable if it's not the network identifier and if it's not the broadcast. If it's either of them, it's not usable. If it's anything in between, we're good to go. Okay. Hopefully this will help you with the lab. I've tried to be as clear and short as I can without going too much detail and boring you to death. Okay. Remember, subnetting, there's lots of ways of doing it. This is just one way of doing it, the way I learned. If you have a different way of doing it, different tricks, techniques, I don't mind what we're doing as long as it works in every case going forward. So like I said, hopefully this will help you. And if there are any questions, post them in the hallway conversations or feel free to contact me anytime. Again, thank you for your time. Take care. Talk soon. Bye-bye.